Hello everyone. Today we are covering a topic from IGCSE Cambridge Chemistry, lesson Chemistry of Environment, topic water. Water is so commonly found all around us. When we go into a lab, it's important that we identify different chemicals, which also includes water. Now, we all know water is colorless and odorless. But so are other different chemicals. There are other different chemicals that are colorless and odorless. So we need to know how to chemically test for water. Water can be tested by two methods, either by using cobalt chloride or copper sulfate. Cobalt chloride in its anhydrous form. So anhydrous means there's no water mixed with it. In its anhydrous form, cobalt chloride is bright blue. When even a small drop of water is dropped onto cobalt chloride, it will become hydrous cobalt chloride and turn into pink. So the color change is from blue to pink. Similarly, if we use anhydrous copper sulfate, this anhydrous copper sulfate is white. And when water is added to anhydrous copper sulfate, it becomes hydrous copper sulfate. And hydrous copper sulfate is bright blue. So the color change that you would see for copper sulfate is white to blue. We are going to look at how to test the purity of water. We can test the purity of water by using its melting point or the boiling point. The melting point of pure water at atmospheric pressure is exactly 0 Celsius. The boiling point of pure water at atmospheric pressure is exactly 100 Celsius. So, if you take a cube of ice, it will exactly melt at 0 Celsius if the ice cube was made out of pure water. But if it doesn't melt at 0, say it melted before 0 or after 0, that means the water that makes up that ice is not pure. It contains impurities. Same with boiling point test. If we take a sample of water and try to boil it, it has to start boiling exactly at 100 Celsius. If it doesn't boil at 100 Celsius, if it boils before 100 or after 100, that means there are impurities present in water. So for a pure sample of water without any impurities, there has to be a very constant and consistent melting and boiling point at atmospheric pressure, which is 0 melting point, 0 Celsius, and boiling point at 100 Celsius. If there are any deviations, that means there are impurities present in the sample. We go to a river and collect a sample of water. What do you think we would find in that water? Usually, would you go and drink, just take a cup and then take some water from a river and would you drink it? No, right? Now let's see why we usually don't do that. There could be all sorts of things in a naturally flowing water sample. There is dissolved oxygen. Dissolved oxygen is actually very necessary, provides necessary oxygen for aquatic organisms to respire. There can be metal compounds. These metal compounds naturally occur in water. Some of these include calcium, magnesium, and iron. Now, we still didn't come to the problematic part. Dissolved oxygen and metal compounds, they're okay. They don't really harm humans or animals that much. Then we have plastics. Microplastics can be present in water from waste and pollution caused by humans over thousands of years. But plastics, of course, for hundreds of years. Sewage. Sewage that means it contains harmful microbes and pathogens from human and animal waste. Now, this had been accumulating in water sources for thousands of years. Harmful microbes such as bacteria, viruses, protozoa, there can be these type of harmful microbes that can cause waterborne diseases. Nitrates from fertilizers. When fertilizers are used in agricultural areas, runoff from those areas can go and accumulate in water sources. So nitrates can also be in water. Phosphate, again from fertilizers and even detergents. It's a very common pollutants that enter water nowadays. Out of all of this, of course, plastic, sewage, microbes, nitrates, and phosphates, these are all mainly introduced by humans. These are harmful. But dissolved oxygen and some of the metallic compounds have benefits. For example, dissolved oxygen is essential for the survival of aquatic life. And some of the metal compounds also provide essential minerals for biological processes. So not everything that is in the water is harmful. Different things in the water can cause very severe adverse effects. Let's look at some of the common water pollutants and how they affect badly to the environment. The first water pollutant is microorganisms. Microorganisms can disrupt biodiversity. The water pollution by microorganism can deplete aquatic ecosystems and trigger unbridled proliferation of phytoplankton in lakes. So phytoplankton is a type of algae that is actually essential for this food chain in aquatic systems. But too much of anything is very bad. If there is a lot of phytoplankton that is being spread, then it could deplete the essential nutrients that are supposed to be distributed over the ecosystem. So that's why microorganisms can affect very badly to especially the aquatic ecosystem. Organic wastes. Organic wastes are biodegradable substances that end up in the water mainly because of dumping or because of natural causes. So when there's biodegradable organic waste in water, organisms will start to break it down. And this uses up a lot of dissolved oxygen. And when dissolved oxygen is used up, other aquatic life who needs dissolved oxygen will have a lack of it. And that could destroy biodiversity. Thirdly, we have plant nutrients. Plant nutrients can cause algal bloom, leading to the death of aquatic life. Again, like I said, too much of things is also bad. Toxic heavy metals. Toxic heavy metals will cause diseases to whoever administers, especially kidney diseases. Therefore, there will be a lack of potable water if toxic heavy metals are mixed with the freshwater sources. Sediments. Sediments are the relatively large type of water pollutants in water sources. Sediments causes clogging of water filters and contamination of drinking water. And there's pesticides, a very common threat nowadays. It contaminates the entire food chain. Pesticides get into plant-based food and then animals eat it and so on. Entire food chain will be contaminated because of pesticides. Radioactive substances. This is a relatively new threat. Because of radioactive substances, kidney damage and increase in the risk of developing cancers will be the biggest adverse effect. And finally, heat. Heat can damage water ecosystems and reduce animal populations. We'll also look at where these pollutants come from. Microorganisms mainly come from domestic sewage. Organic wastes can come from many different sources. Domestic sewage, animal excreta and waste, decaying animals and plants, discharge from food processing factories, All of these can be sources of organic waste. Of course, plant nutrients come from chemical fertilizers. Toxic heavy metals can also come from fertilizers as well as industries and chemical sediments. They get mixed into the water because of erosion of soil due to agricultural and strip mining activities. Pesticides again come from agricultural activities, especially from chemicals used for killing insects, fungi, and weeds. Radioactive substances mainly get mixed into the water because a lot of water is used in mining activities, especially in the mining of uranium containing minerals. And once the water is used in mining activities, they're washed back into the environment. So radioactive substances can get mixed into our natural water sources. And finally, heat. A lot of water is used for cooling processes in big industries and big factories. And when the cool water that is naturally occurring is used to take out the heat from another process, the process will be cooled, but the water will be heated. And that heated water, if it is put into the environment back again, that could cause harm to the environment. Water treatment is something essential that should be carried out before using water. Right now, most of the water sources in the world are already contaminated by the pollutants that we talked about before. So before we use water, water needs to be treated. Otherwise, it could cause diseases such as cholera and typhoid. These are some of the very common bacterial diseases caused by the consumption of untreated water. To prevent this, we have to treat water. Untreated water can contain soluble and insoluble impurities. Some of the soluble impurities are dissolved calcium salts, metallic compounds, and other inorganic pollutants. And insoluble impurities can be soil, dirt, and other organic material. Now, to remove this, first water would undergo filtration. By filtration, we can take out large insoluble substances. For example, the soil, dirt, gravel, and any other large particle, large impurity present in water. But bacteria and microorganisms, they're way too small to be trapped in a filter. So how do we get rid of bacteria and microorganisms? Do that, water should undergo chlorination process. During chlorination, we add a little bit or an adequate amount of chlorine. And because of this chlorine, microorganisms or unwanted microorganisms would be killed. But if you add too much chlorine, that could also be harmful to the humans who are consuming the water. So there is a very regulated quantity of chlorine that could be added to water sources. A while ago, I mentioned that dissolved oxygen is also a constituent in naturally occurring water. Dissolved oxygen is very important for the sustenance of aquatic life. This is because just how we need oxygen to breathe in and survive, aquatic life that live underwater also needs oxygen. But they won't breathe in oxygen the way we do. They need dissolved oxygen dissolved in water, and that is how they could absorb oxygen into their body. So dissolved oxygen is very important. If the dissolved oxygen concentration reduces below the required level, it could inhibit the growth of aquatic animals. Oxygen is usually dissolved in water through the atmosphere or because of photosynthesis carried out by aquatic green plants. During the day, aquatic green plants carry out photosynthesis and create dissolved oxygen. But during the night, just like any other plant, they respire and no photosynthesis would occur, resulting in the reduction of dissolved oxygen. Now that we have covered the theory for this topic, let's have a look at a few past paper questions. From the tests given below, which tests are for water? It boils at 100 Celsius degrees. Turns anhydrous copper sulfate blue. It turns anhydrous cobalt chloride paper blue. The purity of water can be tested by using the first method. Yes, pure water will boil at 100 Celsius. So it is a test for water. Second one says anhydrous copper sulfate turns blue. Originally, anhydrous copper sulfate is white. And when it mixes with water, it becomes hydrous copper sulfate and turns blue. So the second one is also blue. Let's look at the third one. It turns anhydrous cobalt chloride paper blue. What is the original color of cobalt chloride? Originally, cobalt chloride is blue. So upon administration of water, it turns pink, not blue. So if it doesn't turn pink, if it remains blue, that means not water. So the correct test for water is 1 and 2 only. See if we have that answer. Answer for 1 and 2 only. Now let's look at one final question. Water for human use is treated by filtration, then chlorination. What are the uses that do not need water of this quality? For drinking, for flushing toilets, water for cooling industry. Filtration is done to remove large particles. Then chlorination is done to kill bacteria and microorganisms. The only reason that we want to kill bacteria and microorganisms and have very high quality water, especially if we are administering that water. So for drinking, we definitely need the quality of water after being treated with filtration and chlorination. But for flushing toilets, do you need that quality? Of course not. And for cooling industry, for the cooling industry, all that matters is that the water is cool. So not really for this as well. We don't need to undergo chlorination for it to be used in cooling industries. So the correct answer should be 2 and 3 only. Here the answer is 4, 2 and 3 only. With this, we have come to the end of the discussion of this topic. Thank you for listening.